In this lesson, we will use the WinHex utility to assess organizational security. We are in the WinHex portion of the video series, or more specifically, the digital forensics portion. This lesson is part of a video series that prepares you for the hands-on portion of the CompTIA Security Plus exam and is designed to give you hands-on experience with the exam. So what is WinHex? WinHex is a universal hexadecimal editor used for data recovery, digital forensics, and IT security. It is used by computer forensic investigators, IT professionals, and data recovery experts. It is used whenever low-level data analysis, recovery, or inspection of digital evidence is needed. It is primarily used on Windows operating systems in labs, offices, or incident response environments. It helps recover lost data, investigate cyber incidents, and analyze disk structures at the byte level. The how is by allowing users to view, edit, and analyze raw data on disks, memory, and files in hexadecimal format. The rest of the how is what this video is all about, so let's get into it. To get started, grab the companion guide from the link in the show notes below. Also, if you like this content, please like, share, and subscribe to the channel so you won't miss any new videos. So we're all set. We have our companion guide on the left. We have our Windows 10 virtual machine on the right. As it says here, it says this lab introduced students to digital forensics and hex level file analysis using the WinHex tool on Windows. So let's get started and let's get rolling. So prerequisites, we have our Windows 10 virtual machine. We need to go to WinHex, xways.net WinHex, and actually download the WinHex utility, and we'll run it as an administrator. So let's fire up Chrome or whatever browser that you have. I'm going to maximize this for now just to keep things simple, and I'm going to navigate to that URL. We don't want that. We want actually this here. So I'm going to copy this into clipboard and get that in there, and that's the URL that you need. And I'm going to download it natively into the Windows 10 environment so that way you can see it there. I could actually download it on my host computer, but this time I'm just giving you different flavors or different options. We have a download option as you see here. So I'm going to download, and automatically I clicked on it twice inadvertently, but that's not an issue. We'll see the different types of environments here. So I have a couple of other options here. Let's go into our downloads folder in our Windows environment. I did not want to open the utility. We're going to just go directly into it here from my PC. So I'm actually done with the browser. So I'll close this out. I'll go to this is my PC. And while I'm getting there, what we're going to do is actually just look at our regular downloads folder. So let's see what's happening here. It looks like there's a bit of an issue. So issue resolved. Let's go to our folder, File Explorer. We're going to the downloads folder on our local native Windows operating system. I have a number of downloads. Let's go directly into the downloads folder itself, which we have. We see what happened today. And we have WinHex. So WinHex is a zip file. I'm going to right click and I'm going to extract the files here just to make things a lot easier for us. Yours may look slightly different. It's not a big deal either case, because we want to make sure that we have it set up properly. So with my WinHex set up, here's the zip file. I'm going to double click that and I'm going to extract it to the downloads folder. So I'll click OK. You see the display here. I'll click OK and just let it do its work. Now when I minimize this, I should have a WinHex folder here. I double click that and then I have a setup file. This setup file is what we're going to use to actually launch WinHex. Now, if you have a slightly different setup experience, it's because I'm using WinRAR, which is a extraction utility, and the experience is relatively the same. So we have WinHex 21.4. I'm going to accept the defaults. I'm in English, but as you can see, there's Deutsch, Francais, Espanol, Italiano, Portuguese, and a bunch of other languages here. I'm going to just click OK, and it's going to install into the default folder path. And I'm going to accept to create the process in terms of the shortcut And then yes, I will set up complete. I'll run the program so that way we can actually run the program. And then we have WinHex. Okay, so we're set up here in terms of housekeeping. Now, as mentioned before in a previous video, I have shared folders set up on VirtualBox, which is to say that if you go to this PC, I have a Z drive, and this Z drive is peering into my host operating system. So that way I can download files there because I go through virtual machines on a regular basis. If you want to know more about this, click on this link here. It'll take you to the Windows 10 virtual machine setup. It's time-stamped and time-coded, and it'll take you to the shared folders setup. And the reason why I want to do that is I have the bridge file already downloaded. If you're new to this particular video, you can go right into this link and you can download the bridge folder. The bridge file is a PNG file, and it's a picture of the Brooklyn Bridge. And also, we're going to look at sample.txt. And the sample.txt is a simple text file, and it's a sample text file. And you can download that as well into either your local downloads folder. I happen to download it into my host downloads folder. So we're back to the companion guide. We're here at the download sample files because we'll actually use them in a moment. So this is where we are. I'm going to do some housekeeping, and now we're going to check the hashes of those download files. So we're all set. We have our files downloaded in any location that you want. I happen to like the shared folders setup on VirtualBox. And now, because we have hash values, let's go ahead and verify the hashes. So I can actually minimize WinHex for the moment. Let's go into PowerShell, and you can do that by just typing PowerShell at the run line, and it's going to show you PowerShell. You don't necessarily have to do that, but I'm going to run it as administrator just to give us elevated privileges. You're going to get the user account control to make sure that this is what we want to do. So we're going to allow this app to make changes to this particular device, and we'll let PowerShell run. Now, once again, I'm on the Z drive, so I'm going to select Z:, and that'll navigate me to the Z drive. I'll type ls to list the directories. Disregard the red text on black background. For this point here, without getting into too much details, this has nothing to do with what we're working for here, so we can just disregard that. So I'm going to check the hash of the bridge.png, see if it works. So we're going to use the get file hash. I can just keep it case sensitive at this point, case insensitive. It'll do it automatically for me. I can type the algo and do a tab, and it'll do tab algorithm. It's going to be MD5, and let's go ahead, and it's incorrect, of course, because I need to tell it what's the file. Let's see if we can do it this way. If not, I'm going to exit out of this and Control C, and we'll do that over again. So this is clear. I'll do Z, and as always in class, we always mention that labs work best when they do not work at first, so you can see how to work through some of the problems. Control C will get you out of an interactive mode. And once again, I'm going to do get file hash. I'm going to do minus algorithm, the whole thing. I'm going to do MD5, case insensitive, it doesn't matter. And I'm going to call out the bridge file, and I see that the hash matches. So it's Delta 036 Echo 4 Bravo Alpha Echo. And I see I have the same thing here. We can continue looking at the entire file, but I am confident this is the same file. But if you want to be extremely thorough, you can go through that process as well. So I think we're good here. We opened my PowerShell, we downloaded the bridge file, and we also checked the hash. And the reason why we do this, again, is twofold. One, we want to make sure that the file was not corrupted in flight. We also want to make sure it wasn't tampered with in flight by an adversary in the middle. Now, we'll do the same thing with the sample.txt. So we want to make sure that the sample.txt has file integrity. So we don't want that one. We actually want the sample.txt. So I'm going to call that out. And now I see its hash, which is Echo 62549 Charlie Alpha 4 Alpha. Echo 62549 Charlie Alpha 4 Alpha. We can continue. You get the idea. These have been verified as being accurate files and they have not been tampered. This is how the author intended the file to be delivered, and we have verified that as well. Okay, so I'm going to exit on this side. I'm going to exit not on the companion guide. We'll get rid of this and we are good. So I'll scroll up here and we're going to open WinHex because that's the task at hand. Mine was already open, so I'm going to close it so you can see how to run it as an administrator. Okay, so we're going to type WinHex, and you type WinHex, and let's just get rid of this part here so we don't run into any problems. It worked correctly. Microsoft wants some feedback. We'll tell them it worked properly. We'll type WinHex. You can just type Win, and you have the application. And as you know, to run as an administrator, you right-click and you run as administrator, because there may be some tasks that WinHex may need on the device. For example, if we're looking at disk utilities, you may need to run it as an administrator. Okay, so once again, user access control wants to know if we want this app to make changes to our device. We say yes, and we're going to take WinHex as its default. So we launched it as administrator, and the first thing we're going to do is look at a regular text file. So we're going to go into File, Open, and I'm going to go to the Z drive, and I see by file association, Windows thinks this is a text file, and they're right. So we're going to go to a sample text file, and let's break down what we're seeing here. So for starters, we'll work from the offset. The offset here is, actually, let's do a couple of things. We opened here. Let's do a couple of things here, which is breakdown of the display. So hex is hexadecimal. So this means that hexadecimal is base 16. So normally in computers, we're used to the binary system zeros and ones, especially with IT notation. So we have the /24, so 24 bits are slashed. So we have binary, which is zeros and ones. We have decimal, which is the numbers that we use on a regular basis, which is 10, 0 through 9. And we have a base 16, which is hexadecimal. And this is what base 16 looks like. We go from 0, 1, 2, 3, all the way up to 15. And then we have our numbers. We can also use them as AE, and that's how we can identify it. The reason why we do this is because base 16 is a lot shorter than decimal. So we have our base 16. This is why we use it, and we also use it in memory addressing, in DD, in memdump, and also digital forensics. So let's take a look at the first column here, the offset. This offset is where the file is starting in terms of its position. So if this was stadium seating, like if you were in a big arena or let's say a football field, 000 is the starting point, and this is the hexadecimal value of the text that's in that starting point. So if you look here, as we scroll over a little bit into column 3, this is the first line of the text sample file. This is the sample.txt file, and its data, the first line, is in this position, offset. And this is the hexadecimal value of it. So this is first column, offset, second column, hexadecimal. The rightmost column is plain text or ASCII or readable text. It's not always readable text. It could be scrambled, but this is what it looks like. Once again, let's go to a hex string converter to try and give this another perspective. So for example, let's change and go from binary. Let's go from binary to decimal. And I'm going to put in, actually, let's go to decimal to binary, and it'll be fine this way. And we want to just put in the million number, the number 1 million. So it's going to be 1, 0, 0, 0, 0, 0, right? So this is a million. This is what it looks like in binary, which is pretty big. This is what the same number looks like in hexadecimal. So the reason why we use hexadecimal, it's a lot smaller, but it easily converts to binary, and it's all numbers. You just need a table, and we'll come back to rapid table in a moment. But I wanted to just give a brief overview of what this looks like. Okay, so here's WinHex. We have our offset number. This is the location of the data. This is a hex representation of the data. And this is, if possible, column 3 is a human readable section of the data. And we looked at a string rapid tables to look at hex to string converter. Okay, so now let's move over to common files, also known as magic numbers. And these numbers are specific numbers that begin at a file to let you know that the file is the type of file it is, even if its extension has been changed or is misleading. So let's take a look at this. I'm going to open a PNG file. So I'm going to go to File, Open. I'm going to navigate to my Z drive. I'm going to open the bridge, and it's a PNG file. I'll click Open. And the first thing that happens is this byte string here is 89504E470D, 0A. This first byte, or the magic numbers, identify this file as a PNG. All PNGs will lead off with this special number. I can verify that by taking this number here. I'm going to copy it into clipboard. Let's go back to rapid tables. I'm going to now convert hexadecimal to text. I'm going to put in my value here. And let's see, what do we get? And we get PNG, and you see this PNG here. This is how we can identify files even if their extensions have been changed. So let's take a look at this a little bit more. Now, this particular table are the common file signatures. Let's take a look at a PDF. I'm going to open a PDF. So if I'm doing some analysis, here's a sample PDF. I'm going to open a PDF. I know what the extension says, but I can open it in WinHex. And I want to make sure that the first byte, its file signature, its DNA, is going to be 255044462D, 255044462D, and this gives me %PDF. I know this is correct. Let's see if we have a zip file available to drive this point home. Let's see if we have a zip drive available. I don't have one handy. Let's see if we have one in software. Let's see. If we don't have one, it's not the worst thing in the world. And actually, let's see this here. This is an archive. It's a zip file. Let's see, what do we have for a zip file? A zip file is a PK, a dot. It's going to lead off with 504B0304, 504B0304. Okay, let's go to this executable that we have here. And we're going to go to Open. I have an executable under Sample. And let's go back to, actually, we have to go up a little bit. We'll go to our sample executable. It's an application. It says here, it says .exe. I open it up and it looks like my text file. And lo and behold, I'm expecting to see a 4D5A for an executable, and I don't see it. This looks like a regular text file, and this is exactly why we would use, one of the many reasons why we would use WinHex, because we're trying to find a wolf in sheep's clothing. So let me show you what that looks like and exactly what that is going to be, something that we're looking out for. So this is an example of wolf in sheep's clothing. There's a file in our file system that's masquerading as an executable, but it really is a text file. Now, we did this to keep it really simple because we didn't want to cause any additional problems, but you can see how if we're allowing certain types of files into our system, simply renaming it will solve one problem. But if we go into a hexadecimal, we will see the offset or the common signature, and we know, although this says that it's an executable file, it says sample wolf in disguise .exe. We know this is a text file because we have examined that file. So that's one of the reasons why we would do this. Let's take a look at what a real executable file will look like. We're expecting to see the 4D5A common signature. So we'll come into Open. Let's see if we can find OpenStego is an executable. Let's see if it really is an executable. And it has the MZ ASCII note MZP, I see that here. This is fantastic. And I also see the 4D5A common signature. So that's one of the reasons why we would use a hex editor, to make sure that files, even if their file extension is incorrect or misleading, we can verify it by opening it up in a hexadecimal editor like WinHex or HXD. There's a couple of other ones out there as well. Okay, so I have my file open. It's an executable. Let's go ahead and let's do our, make sure we have housekeeping in here. Let's take a look at the file properties of this one. So we're going to go to File and Properties, and it's going to give us a little bit of information here. So we see the file size. So it's a 1.7 megabyte file. We see that here as well. Check. We see the creation time. It was made on May 30th at 5:42. Great. The last write time, and it was saved to disk. This is good. And we also see the last access time. When was it actually accessed or someone used the file? So we can see all of this information in WinXD as well. And of course, when I say WinXD, WinX, but there's also HXD, which is another version of this, but we'll stay into this process for now. So now we want to navigate through the hex window and look at the hexadecimal data. So one of the things we can do here is, I'm at the top. If I want to jump down to the bottom, I can do Control-End on my keyboard combination. It'll take me to the end. I know I'm at the end because it tells me the file size. So this is the 1.7 megabytes of file space. I'm at the end of this file, and I can quickly scroll through to see if there's anything that jumps out at me. So I'll scroll over here, and most of this is scrambled because it truly is an executable file, and a lot of it is not human readable. It's actually just regular code. If I go to my sample text actually has regular human readable file information. So I can do Control-End to get to the end of that file. And this file is a 4.1 kilobyte, and I see the last space of its memory. And I can do Control-Home to get to the beginning of this file. By the way, text files do not have a common signature. They just jump right into it. For example, if I was to take this block head, I'm going to right click. Actually, I'll just go here. I'll go to Edit. I'm going to copy the block, and I'm going to copy it as a hex value. I'm going to go back to rapid tables. I'm going to put this hexadecimal value in, which is the 5468. I'm going to convert it, and it says this is. So plain text files do not have common signatures. They get right into the text and convert it into hexadecimal. That's just something to know. So we're going to navigate here. So we're all set. If you need to find your way around, let's say we know this is the common signature for a zip file, 504B0304. Let's go back to our zip file here. Let's just say for whatever reason you were in this section of the file and you needed to find a particular hex value. You can go into search and you find a hex value. You go ahead and put in the particular hex value that you were looking for. In this case here, it was, let's see if that's the right one. I'm going to 504. We click OK, and it takes me right into that particular hex value. So that's how we find text values. Same thing can be done if you're looking for text in a file. This is like the Control F that you're normally used to. We can go to search, find text. In this case here, I'm going to say what 37th is. Let's see what that looks like. I think I had numknock off on this here. So this is always helpful. And let's see what do we have. And then it goes right into the text. I was looking for the 37th line of the sample file. So you can either search via text or hexadecimal value here. Okay, so the bridge file. The bridge file, as you know, this is the bridge.pmg. We can compare and look at hexes as well. I'll probably do this on a text file because this is what it says on the companion guide. So we'll come over here and take a look. I'm going to go to Tools, and I'm going to compute the hash. We're going to use MD5 because that's what was given to us before. And I get the number, which is incorrect in this case here. Let's just make sure that's right. I have an 8B, Or is that correct? This looks a little different. So it looks like my sample file was altered, and that's more of a me issue and not a you issue for this case here. But if we wanted to look at the file, let's just see if the PNG is going to do it for me. I don't think I altered that since I started this lab. So let's go to tools. Let's go to compute the hash. We're going to do an MD5, and it's going to give me the D0. Let's see if that is correct. I remember this here vaguely. So I can compute the hash of a file right from WinHex as well. So that's one of the things we can do as well. You can go to PowerShell and use the get file utility, or you can compute the hash itself. I can compare it. I can copy it at this point here. And if we wanted to, I can insert it. As you can see here, I didn't do that properly, but we'll fix that in a moment. Let's go ahead and see if we can get that to work here. So I'm going to compute the hash, MD5. I'm going to copy it into clipboard, and it's possible that I don't have my clipboard enabled bidirectional. So that's why that's not working. So we'll disregard that for the sake of the video. So from time to time, I'll allow myself to paste from my host operating system to my virtual machine. I do not let my virtual machine paste to my host operating system, and that's why that didn't show up at this point here. But all good. So you see how you can compute the hash. We can recover deleted files. We're going to Tools and Open Disk. And at this point here, you see all the disks that we have. I have my VirtualBox guest editions. This is the local C drive, and these are the local storage spaces here. So these are logical. This is the physical. If I want to, I can go ahead and get a snapshot of my partitions. And then if we want to, we can actually do tool to file tools, and then we can recover different types of data that was deleted and also put into the recycle bin. We'll dive deeper into that when we look at FTK Imager. That's going to be a nice lead in into the FTK Imager on how to recover files where users or a person of interest may think that they have deleted a file, and this is how we can actually recover that file. But you can do that in WinHex as well. And then last but not least, let's go ahead and we can clone a disk. FTK Imager is going to allow us to do that as well. It's a little bit more robust. So we go to Tools, we open Disk, and in this case here, I'm going to go into a slightly different area. This is where we go into our Tools, and our Disk Tools options is where we can find the Clone Disk option. And this allows you to replicate data, whether it's a USB drive, the local drive, you can clone it. The reason why I'm sharing that information here is because this is Windows, and WinHex has that capability. Truth be told, a lot of this is done on an FTK forensics tool, and we'll spend some time on that in the next session so you can see what that looks like. But I wanted to point out that you can do that in WinHex as well. And then we also can do file comparisons. So in this case here, I'll show you how to close out some of these. You can close this out. You close this out as well. You close this. And of course, you can close them out as well. So I have my PNG file. I'm going to open another file, or I can just do Tools, and I can compare data. So the bridge PNG is disk data source number 2. Let's go ahead and compare it to, let's say, data source number 1. So I'm going to navigate. I don't want this one. Well, obviously we're not going to see any differences there, right? So let's go ahead and do this from scratch. So I'm going to cancel this out. We'll go to Tools, Compare Data, and they're empty. So my first data source is going to be bridge. Okay, and my second one is going to be hidden. And this is if we suspect, like in the previous lesson, we looked at steganography, and we suspect that the files are not the same. So we click OK, and it says search for all the differences. And it says it's going to create a report for us. It gives it some time. This usually goes fairly quickly, a couple of seconds, and it sees 4 million differences, and we can take a look at Notepad to take a peek at them. Now, when it opens it up, it's going to show us the original value For example, bridge, this is the file size, and hidden, this is its file size, and it's telling us at offset 48, this is what it looks like in the bridge.png, this is what it looks like in the hidden.png, and it lists all the different changes. So if we suspected that a file was changed, or more specifically, hidden.png has an embedded file in here, we can go through that byte by byte and analyze it. And of course, you can take this information, throw it into your favorite generative AI tool like Gemini or OpenAI or Anthropic, and it can recreate that data for you, assuming it wasn't encrypted. So once again, it's a high-level view of WinHex, a Windows hex editor, and you can learn a little bit more by visiting WinHex. Here, it gives you some background into the tool. The point of this exercise was to give you a little bit of background into it, some familiarity if you haven't used it before, and of course you can get help with this. We will dive deeper into the digital forensics in the FTK portion, which is the next lesson up, but I wanted to just tease this topic so we have this in our toolbox as well. So I hope you enjoyed this session as much as I enjoyed preparing it and delivering it for you. I'll see you in the next lesson, FTK Imager.